Texas A&M enrolls over 60,000 students. Over 1,100 students have physical disabilities. The percentage of disabled students has risen from 1.5% in 2005 to almost 4% in spring 2017. Texas A&M has one of the largest campuses in the country. East Campus is over 5,000 acres. Even students without physical disabilities have trouble getting to their classes. To better serve students, Texas A&M Transportation Institute, or TTI, has been developing a fleet of autonomous vehicles. Each vehicle is capable of driving without human assistance and can carry up to 3 passengers. Several groups of engineering students have been working to make this system a reality at Texas A&M. As a part of this project, our team has been working with TTI to determine how many vehicles it would take and the best staging locations to serve the growing population of students with disabilities. To understand the distribution of students on campus, we gathered data from the registration office. From this, we were able to see where the highest demands for the shuttles would be on campus. We also learned how the demand fluctuated throughout the day. We identified the 5 buildings with the most demand as Heldenfeld's, Blocker, Weiner, Heck, and the Kim building. You can see from this graph that almost half of the demands are from these 5 buildings. We applied the demand data to a campus map. We used this graphic to select probable locations for staging areas. When selecting probable locations, we considered the demand in that area, accessibility to major campus roads, and if the area had the necessary electrical and structural requirements to store shuttles. Finally, we needed to know how much time it would take for an autonomous vehicle to travel from its staging location to any building on campus. Using a software called ArcGIS, we measured the distance of routes to be taken by the shuttle from each probable staging area to each building on campus. This distance was then turned into a time by the general speed of the shuttle. We reduced the total demand down to demand for disabled students by assuming that they are a subset of the general population, an assumption which we confirmed with disability services. Using the data we had gathered or created, we formulated a linear optimization model. This model outputs whether or not each of the probable staging locations is necessary. What we have found is that there are decreasing marginal returns on the number of staging areas. In other words, for each staging area added, the respective benefit becomes less and less.
We have found that Central Campus Garage performs best alone. But taking into account the high student density around the parking garage, we suggest an alternative by implementing 2 locations, Coldus and also Lot 23.
Texas A&M is a place where problems do not go unsolved. Students and faculty are committed to finding solutions which benefit all people. We are the leaders in innovation.